link and everything. Greetings, fellow nerds. Welcome to another intriguing episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from protocols old and new to industry trends and drivers to up-and-coming technologies, and, as always, things you should know to further your career. And Mr. Tansura, how are you today?
Doing great, and great to see you, Jeff, as always. And Yingzchen, welcome.
Yeah,
Yingzchen is almost family.
That's right.
We've been co-chairing routing working group for many years, so we have ITF relationship. And Jeff, do you want to do introduction for Yingzchen, or I can do it?
Go ahead. Yingzchen has joined us in the past on a previous show, but you guys work so well together. I've been to a few IETF conferences and seen you both up there, but why don't you do the introductions?
Yeah, so Yingzchen is absolutely amazing person, besides anything else. And we've been co-chairing a routing working group probably 5-6 years together. And Yingzchen is also chair of LSR working group. This is where these weird animals called OSPF and SAS live and eat each other. Right. So thank you for coming. And I think it's a very important topic we're going to cover. And I'll let Yingzchen to explain how we started this work and why, because 47, BGP before was around for a really long time, right? There's billions of implementations, but practically at some point you realize that what's described there is not good enough. It's too vague, it's too undeterministic, so you really need to dissect FSM as described in 4271 into much more details if you want to do something with it, if you want to change something, right? We are talking about distributed system behavior. So Yingzchen spent probably best 6 months of her life dissecting BGP FSM, and we would like her to share her work. So there are more people involved in this work, but she's driven it. It's really her work, I would say. And please go ahead and lead the discussion.
Well, I should add too. I mean, for the BGP finite state machine, you can read almost any book beyond extreme basics on BGP, and you're going to see some version of a diagram of the finite state machine, including my own books. What's important to note, and I think Yingzchen, you're going to be talking about this, is that we almost always, for the sake of an illustration, tend to struggle to simplify that state machine, and the reality is there's a lot of complexities behind it, and really interested in seeing where you take us on that.
Okay, thanks for having me here. It's a pleasure to come back. Last time I was here talking about BGP over QUIC, and this time Jeff called me and asked me to talk about BGP finite state machine. And this is a very specific topic, covers a lot of details. Even some like people who does BGP development, BGP developers, they may not even look at the finite state machine every day, right? Nobody look at it that carefully unless you are really doing the finite state machine development. And so, but for us, because during the process to design BGP over QUIC, we have to look at BGP finite state machine really carefully. And this gives us the opportunity to read the RFC Section 8 of 4271, at least for me, many times, back and forth. And so look at it more carefully, I realized, a lot of things I didn't think of before. So today, thanks for giving me the opportunity so we can share some details of the BGP finite state machine. Now we can have some slides. show the slides, and we can look at the slides. The BGP finance state machine, most of the time, when you see, maybe, okay, let's try to enlarge it. This is the picture you see online or in a lot of books, similar to this, or describe the big 6 state in BGP finance state machine. This is the one I got from Wikipedia, but a lot of time you see similar pictures. People say, oh, this is how BGP finance state machine works. And people look at it and say, oh, okay, I just have this big state. I have some state transitions, and that's it, right? People focus on BGP features, like how those NLRI designed. They may not how community works. They may not even care about how the state are transitioned. They just say, okay, that's the picture. That's I understand how it works, but I need to show you close to real BGP finance state machine picture. This is how it really works. The comments I get most of the time when I saw this slide, they say, oh, you got to make the picture is too small. It's not readable.
Yeah, I was going to say, if you gave this to a book publisher, they would faint.
Right. You definitely cannot publish this in a book, right? But the point of showing this picture is to show this is how the BGP what the BGP finance state machine really, how it really works. It's this messy. It's meant to be not readable, and even this is a simplified version. I removed a lot of lines transition from one state to another state. It might be triggered by many events, so you have a lot of transition lines. I simplified them to one line. So the picture
20 to 40% of more details.
Right. So this one is simplified version of BGP finance state machine. It's just not simplified to this level. This one you can still see a lot of sub-state. Jeff has to call them sub-state in one state, in one of this big state. So now let's look at, just look at the connect state. This will give you some idea, because this one is not really readable. But we look at one state that may help you understand. The tool I use to generate this picture is an open source tool I found online. It used this sort of descriptive language, and it generated the UML. Use the UML and generate. This is an SVG picture generated. So let me enlarge it a little bit further.
Yeah, so before you continue, probably we should say, why should you care, for people watching? There are 2 categories of people, like people who develop BGP, people who use BGP. If you're a developer and you are trying to change or enhance BGP, you definitely should understand this. That discussion came up in ATF during Centimeter discussions. So we are trying to enhance everything we use on internet, right? That includes BGP.
Yeah, so why do we want to do this exercise? This is an important topic and we can cover. So even when 4271 was written, right, whether to include Section 8, the FSM definition, people were debating about that. Because a lot of people's idea was this, the implementation of a FSM is really up to an implementation. It should not be defined as part of the standard. It's totally internal. To a level, I agree with that idea. Like how you define those events, just like whether when you do a programming, whether you want to use an array or you want to use a queue. It's your internal implementation thing, right? What sort of data structure you want to use for FSM implementation is to a level is the same idea. But it's important for people to do when people want to make extensions to BGP, modify BGP, how BGP works. You have to really understand how the finite state machine. So when you design a new event or add a new timer to the BGP, you need to make sure your finite state machine doesn't stuck in a certain state. You have to understand the whole flow of the finite state machine in order to make sure your design is correct. So we went through these exercises when we did the BGP over QUIC finite state machine design. For BGP over QUIC, we have the control channel and the function channel. The control channel is responsible for manage the quick connection setup and also the BGP finite state machine part. You from the initial from the idle state to established state. Only after the control channel reaches established state, then function channel can start be. Then you can create a function channel. So really, the control channel of the BOQ is essentially the same as the 4271 finite state machine. So, but during that, but we do have some modifications because we need to move like a TCP related event to QUIC related event. Also because we are using QUIC streams, so we have stream level event. So we have some modifications to the original finite state machine. Then I went through this process to really draw all these pictures for every single state to make sure we don't have any event or something that's, you may, so we have altogether 30 events. So you have to make sure in every single state, all those, what happens, if one event happens, you have to have a procedure to deal with it. Even it's just, you say, oh, in this state, this event, when this event happens, you just ignore it. Even you just say that, it has to be, you have to make sure all 30 events are handled in every single state.
So I really wanted, before you continue to bring, why do you care points, right? Formal specification should be specific enough to implement bug-free code. I mean, bug-free code doesn't exist, but as close as it could be, right? So if you look at GR, that is somewhat underspecified, and math in implementations, I mean, there probably have many interpretations, their implementations and what they do with it. At class, to some degree too, I think we really want to avoid this. So if there's enough space to wiggle in implementation, eventually you will build two things that don't work with each other or work in really weird ways. So here we are doing the work to avoid this in the future as much as we can.
Yeah, so there are some events in a state, when that happens, you just ignore it. And there are events in a state, when that happens, it's considered a finite state machine error. When that happens, you literally change your state back to idle. So a lot of times, these are like an event that theoretically should not happen when you are in one state, right? So like, for example, in established state, if you see a menu star event, you ignore it. But if you didn't define it, you are not including it in your definition. When developers do the development, right, do the coding, they may say, oh, I can just consider this a finite state error. And then your state will be changed from established to idle. That's a big deal, right? So you don't want to underspecify anything.
Yeah.
And so on top of development, there are people who try to build troubleshooting tools based on BGP state transitions. We tried with an upstream member with Jeff. There are other companies trying to do it. So practically, if you don't understand the transitions, or even worse, when code makes a transition in wrong way, your troubleshooting is garbage, right? Garbage
Yeah.
into the cloud. So doing this correctly is, again, it's absolutely important for operating the network. You need to understand why your BGP is in a particular state.
Well, and it's whatever implementation you have, is it a safe or maybe a secure assumption that any change you make to the finite state machine, even though it looks like it's internal, is at some point going to impact interoperability with other BGP implementations?
Yes, exactly. Actually, let me show you this. This picture, I actually integrated the graceful start into it, right? So when graceful restart defined for BGP 4724, if I remember right, it changed the finite state machine. So when your BGP is in established state, depending on whether you have graceful restart functional or not, right? Whether you have graceful restart enabled or not. When there is another TCP session coming, that changes how you treat that new connection. You have to look at, oh, this is for graceful restart or not. If it's not, if you don't have graceful restart enabled, you have to go through the collision process to figure out whether this is a collision or not. But if you have graceful restart enabled, you know, oh, this is you are going through graceful restart. That's another TCP session coming up. I need to drop this one and go to continue on that one. So the collision detection process is totally different, and that need to be embedded, work together with the existing finite state machine. And so for recent works, we have the BGP send hold timer. That also changes the BGP finite state machine. And there is another draft that's at the BFD strict mode. That changes BGP finite state machine as well. The send hold timer is relatively simple because it only works in established state. When your BGP is in established state, somehow your remote session has, for example, may have a 0 size receiving window for TCP. So you from your side, you see, oh, I'm sending all my packets okay, but somehow it doesn't get acknowledged or it doesn't get processed on the other side. And theoretically, your hold timer should expire, but these days you may have the other side. People use multiple processes to handle different events, and then the communication you have some bug. The communications between different processes are not working as it's supposed to be. So you have this stuck TCP connection. The send hold timer in this case will expire and cause you to terminate your BGP session and get a reset. Yeah, that's the basic idea of the send hold timer. And the BFD modifies the finite state machine more because it's in the connect state. Connect state is relatively more complicated depending on whether like you have delay hold timer, delay open timer, whether you have what your hold timer value is. Anyway, you got to also, if you look at the connect state, right? From connect state, the big block in the middle is really the connect state. You can transition to idle, transition to open send. Hold on, let me see. Active. So you can have a lot of state to transit to. That's why it's more complicated. Not from like a established state. You don't have that many state to transit to. So in terms of finite state machine, this is more complex. And by doing this, I realized, just show you an example, from connect state, there is under certain circumstances, you can transition to open confirm state. But you don't see that in this picture.
Yeah.
And back to operation troubleshooting, you observe it being particular state and you have no idea. It's not even present in 4271. So what
Right.
we do is
You have to look at 4271 really carefully, think about it, doing some exercise like this, you realize, oh, because when you are reading that section, right? If you are not really doing coding, you probably won't think it that much. Really, when you have your delay timer, delay open running, you receive an open message. That's when that happens, it's possible you may transition to open confirm state directly. But when you just read the RFC, at least for me, I won't be thinking that much. Yeah. So, but going through this exercise made me realize, oh, I can go to open confirm state, but I don't see that in this picture. You see from connect state, you can go to open send active idle, but you don't see a line from open to open confirm directly.
And I think also what indirectly kind of drives to this complexity is that we by default negotiate more and more capabilities. So if you go into your favorite router and do some kind of analogous of show IP BGP neighbor, you will see how many capabilities have been advertised, received, negotiated, and a lot of the stuff is done under the hood. You cannot configure it, you cannot disable it. So it's a combination of different features that makes it really complicated. And the devil is always in details. How does different things interact with each other? And since a lot of our shows are focused on data center, you've got many, many BGP sessions on single switch, right? On a modern 51 tera switch, you could have up to 5,000 BGP sessions, right? So they start to interact with each other. And at the scale, you get to see stuff that you would never expect BGP to do. This is why I think this work is kind of more and more important. We need to clearly understand BGP states, potentially publish a document that explains them in details, and have developers to understand it better when they push a new feature without really thinking of all the consequences.
Yeah, especially if you have that many sessions going on and you have one session that keeps flapping, right? You want to be able to quickly figure out what's going on there and troubleshoot it. There might be just like a BGP fence state machine have one mandatory session attribute and optional session attribute. You have to make sure all the optional ones that if they are configurable, you have to make sure all the configurations are correct and they don't conflict with each other. Right? In reality, a lot of the times we get people complain, oh, this is not working. At least from my experience, more than half of the chance that they have the configuration wrong. Yeah.
And so while not topic of this discussion, instability in BGP leads to system instability. You see what's happening in RIP, next hop group explosions. There's a lot of stuff that flapping BGP will cause. Eventually, it will move down the network if it's unstable enough, right? So getting the stuff right is fundamental for working network.
Yeah. So, but going through this exercise really helped me to understand how the BGP finance machine works. And this also is very essential, very needed step in doing the BGP over quick design. Yeah. So like this, for example, in this picture, right, we see the established state, and we actually put in the, let's see, this is a little bit larger, whether depends on the GR, whether we have GR enabled or not. I integrated the graceful restart 4724 into the 4271 finance state machine, the basic one. And so basically integrate them together, you'll know, okay, the design works. You don't see, if you see something like, okay, after I transition, I'll give you an example. If you don't see this line, you see, oh, I just have a single block here, then you know your design is wrong. You have a state that once you transition to it, it's not going anywhere. Rarely, unless you have a terminal state, right? You go to that state, you consider your job is done. Otherwise, you have to have a line also going out to transition some other state. You need to make sure the entire process flows. Yeah. So I don't know how much detail we want to cover. All this. This is pretty much this picture illustration of 4271. The number I have are the BGP event number that defined in 4271. Although it's not in 4271, it says, oh, this is just for description purpose. The number is up to implementation. But recently, we did another version of these numbers at IETF. And Jeff Haas is the main driver for that because there are so many drafts later. When updating the finance state machine, we want to make sure the numbers stay consistent. Yeah, so I think right now the number in 4271 is event 28. So later, for example, Jeff Doyle, you define a new draft. You define, oh, I want to add another event 29. Mm-hmm. And later, I get another extension to BGP finance state machine, but I didn't read your extension part. I only care about the basic one. So I may define another 29. Then doesn't look right? So by having an IANA registry, I know, oh, there is already 29. I should start from 30. Yeah, that helps the overall maintenance of BGP.
Yeah, so I think network complexity is another kind of favorite topic of the show. What you see here is very, very complex. On another side, we always say we choose BGP because it's that simple. We understand how it works, the transition is obvious, and that's why we see BGP pretty much everywhere, right, in data centers. So I think the goal here, as Russ White would say, complexity never disappears. You can just throw it over the fence to someone else.
Yeah.
Right? Someone has to deal with it, and hopefully it's us in this case. And the idea is to have well-defined events, transition of events. So you as consumer of the technology can be sure that when you introduce new functionality, or actually on your behalf, your favorite vendor does it, there's no ill effect of different things interacting in a known way, especially in multi-vendor environment.
Yeah, so when people are looking at BGP, most people look at the features that BGP can bring in, right? You look at VPN services, eVPN services, VXLAN that can, BGP can carry such kind of information. You troubleshoot, you debug all those routing related information. All those happens when BGP already reached established state. But the finance state machine is the foundation that can make BGP work. You have to reach established state first before you can carry all those routing related information. Yeah. If for some reason your session is now coming up, you're stuck in certain state, or you just keep resetting, and then forget about all those advanced features, nothing is gonna work. So this is really the essential, the foundation piece of BGP.
So if it's not DNS, it's BGP, and if BGP doesn't work, nothing else does. Simple as it is.
Right. So this is really the foundation of BGP. If you don't get their finance state machine app, there is no BGP, period.
Yeah, so to our listeners, we wanted to give you an update of what we are working on, and it's really important work. So you will see this work in ATF in different kind of ways. You will see reflection of this work in BGP over Quick because there's a lot of events that need to be redefined. Most importantly, for current BGP, you will see explanation or dissection of state machine defined in 4271 that will help developers to write clean code, that will help users of the technology to better understand why they are in particular state.
Yeah,
right?
so it just happens that when we are working on the BGP over Quick, we went through these exercises, and this also benefited the BGP send-hold timer and the BFD strict mode draft. They sort of say, oh, you already did this, and then there are something we can use, right? We learn from this process. So that makes the have those two draft to progress. We didn't think of that when we were, really doing the BGP over Quick draft. We didn't think that much, but really now I look back, I say, oh, that's some exercise worth doing. Although I have to admit, I did spend a lot of time on this. I went through several iterations using different tools to figure out what's the best, the picture generated by tools all look different, and you have to pick some reasonable tools for illustration purpose. As an IETF, ideally, if it's an open source, relatively stable open source tool is the best choice for us. Of course, there are a lot of commercial tools available, but not everybody can afford to buy those expensive tools.
So practically the intention is to make, so for all this work obviously to be public and available to all the consumers, and hopefully make BGP better understood protocol.
Yeah, so if you are interested in this finance state machine diagram, so I did a presentation at IETF 120 in the IDR session. Jeff Heiss and I did jointly together. He talked about BGP finance state machine, and also when we talk about BGP over Quick, these pictures were included, including the information to the tool, how the text was you can get all the information from the IETF website. We have the slides available there. And I can also, I don't know here, I don't mind post the slides here, but I don't know whether you guys have a GitHub or
so we can have a link to the slides if you upload it someplace on YouTube.
I can put it in my GitHub and provide you a
even better.
Yeah.
I plan to put this. Yeah, I can put this into the BGP over Quick drive. People interested can take a look. The GitHub repository. Yeah.
So I think this is pretty much what we wanted to discuss. And I, again, would like to thank Yingzchen to joining us and sharing her wisdom. And please do follow up this work. If you work on BGP, this is really important. And it will make you better network engineer. Understanding protocols is foundational to being a good engineer.
Yeah, this really help you to understand how BGP works. Especially, when you're troubleshooting BGP, the interaction, how it interacts with TCP, right? A lot of things. You don't see it, maybe not every day, but when it happens, it's typically a hard problem to troubleshoot. Because not all the TCP implementations may provide you the same API, same information. So if you understand the finance state machine a little bit better, you may know which part is wrong. Yeah.
Okay. I think we are close to the end of the show.
Yeah. Yingzchen, thank you so much again for joining us. And this was sort of a last minute change in our topic, and you stepped right up there. And
yeah, thank you for having me here anytime.
Thank you so much.
We will definitely have you back.
We can just talk about something, randomly, or OSPF, ISS.
There you go. We should. I don't think we've ever. Jeff and I are always so focused on data center. I don't think we've ever just correct me if I'm wrong, Jeff. But
No. So we had Tony Lee and we had Les Ginsberg talking about ISS here, actually in great details. We also plan to bring people and talk about what's next for IGPs.
Les definitely know ISS much better than I do. If he was here, then okay.
So yeah. I think it's still on our to-do list, and there's a lot of development in IGPs. And again, Yingzchen is the co-chair of Link State Routing Working Group, so there's very few people more suitable than her. Practically, sometime in the close future, we plan to bring most of these weird IGP people on board and try to discuss what's going on. What's next?
We can bring some IGP people. Not sure about the weird part.
Yeah.
Don't let me bring OSPF shoes to the discussion.
Well, yeah, I do have my OSPF shoes though. But anyway, so yeah, IGP is classic, right? So not everybody think it's interesting anymore, but it's really the foundation to make your routing work. In your BGP domain, you may still need IGP to run, especially in service providers network, right? So you still need to run IGP.
So it's on our to-do list. We do remember, and we plan to do it eventually.
Yeah. IGP still has a lot of advantages in terms of convergence compared with BGP.
Yeah.
Inside your domain. That's something you may still consider.
We should do a show, maybe a couple of shows on segment routing at some point too. If we put our toes into the service provider space, you pretty much these days have to talk about SR.
Yeah, these days data center is definitely attract all the attentions, right? But
yeah.
Service provider
SR is being deployed, being developed. It runs today pretty much in every network, especially SR and PLS. Yep. And it's a very close topic to my heart. And maybe we should indeed discuss what's going on in this world, because it's been, 8 years since active work on SR started in ITF, and probably almost 20 since we in Redback Network did the proposal. Much before anybody knew what SR is. But
yeah. All right. Well, this was a short but very informative show, and Yingzchen, thank you once again for joining us. And I think we'll wrap up here.
Yeah.
And Jeff, see you back in 2 weeks. And for everybody here, I'm sorry, what were we going to say?
I didn't cover a lot of details for the financing machine transitions because I don't want to bore everybody. But if you are really interested, please don't hesitate to contact us for the details. Yeah.
If anyone out there is a true nerd, this is not boring at all.
So please use probably LinkedIn as a platform to initiate the discussion.
I really didn't want to talk about, okay, when you have your delay open enabled, what do you do when you receive an open message?
You run away.
There you go.
Yeah, so that's really probably too much detail, right? Whether you should send you have your delay open, whether you want to send the open, you want to wait for an open message. That's really, I don't know. So, but if you are interested to that level of detail, please don't hesitate to contact us.
Absolutely.
Thank you.
Thanks everybody for joining us, and we'll see you again in 2 weeks.
Thank you. Bye.
Thanks. Bye.